Hey gang, we're going to go through speed and problem solving. So this is more about the problem solving method that we use. We use a four-step method, and as we go through, I want you to follow along with me and write out the problems. So we'll get into that here in a bit, but this is not so much as like how we just do this for speed. This is really a method on how we solve out problems and how we think through problems, because sometimes we will get stuck, or there'll be things that we usually kind of do in our head really fast, but this is a way of actually thinking through it and making sure that if we do get stuck, we can get ourselves unstuck, we can figure out the problem. And so that's kind of the big thing that we'll be doing. It's a way of thinking. So doing it with speed, that's just the cool part. Okay? So when we talk about speed, just like what we did before, it's a distance traveled over a period of time. There's a main equation that's associated with it, but there are two other equations that go along with it, just kind of rearranged, like time is distance divided by speed, distance is speed divided by time, time is time. But we're going through problems, we're going to use this equation as our primary thing. And again, most of it's pretty common sense, like the letters are abbreviations, and D stands for distance, and T stands for time, and V, it actually stands for speed. But why a V? Why a V? It's because it stands for another word that's closely associated with speed, and it's velocity. So for what we deal with in class, speed, velocity, they're kind of the same thing. Okay? When we solve out problems, we'll go through all this stuff together, but really these four steps is kind of identifying or listing things that we know and things that we don't know. Okay? And then we can write a relationship that goes along with it to help figure out what we don't know. So writing an equation and then taking the things that we know, substituting in, and solving for what we want. As we go through, there are going to be some things that we need to keep in mind, things like units and giving our answers, like it should make sense, things like that. But on your paper, what I'd like you to do is make sure that you have this page set up. You should have your name up at the top, and then also along the top, these four columns where it's going to be list, equation, substitute, and solve. And we're going to also list out what problem that we're solving out over here on the side. So we're going to have four problems. It's example 1, example 2, example 3, and then this is the one that you're going to do at the end. But this should take up the entire paper, so kind of space out those four problems, and then the columns should also take up the width of the paper, so you can space out those four columns, the list, the equation, substitute, and so on. So we're going to solve out these problems. And like I said, I'm going to go through one after the other. Feel free to pause the video if you need to. I'm going to be going through them just one after the other, kind of spelling things out as we go. I want you to copy down the work that we're doing together. And so what's written down in these four areas, I want you to have in your four areas for each problem on your paper. And those are going to be the things that you need to show. And then, like I said, feel free to pause as we go, and if you need to, or if you just need to catch up with stuff, that's okay. So, when we read through the problem, it says the world record for a marathon 26.2 mile run was set in 2018 by Eliud Kipchoge. He finished in 2.02 hours. On average, how fast did he run in miles per hour? So when we solve this out, again, keep in mind, this is example number 1, and it's going to go in this spot for example number 1. We're going to go through each of these steps. We're going to list what we know and don't know first. So when we do that, I actually look up at the problem, and I look for things that kind of stand out as kind of like a mathy thing, and that's fine. So it says here it's 26.2 miles. But when I see 26.2 miles, it's not just a number, it stands for something. It stands for something that goes back to this equation, and it's either a speed or velocity, it's a distance, or a time. And 26.2 miles, that sounds like a distance. but I'm going to abbreviate it just D. And over here in my list, I'm going to say D is equal to 26.2 miles. I'm going to include a unit, and I'm going to abbreviate MI for miles. That's how you abbreviate MIs, and it's not, or miles. We don't just use M because M, that means meters. So we use MI. Then, other things, 2018, well, that's a year, but this 2.02 hours, that's the other part that stands out. And when I see hours, I'm thinking of a time. But I just abbreviate with a T. And so in my knowns information, I put T equals 2.02 hours. And I abbreviate it just with an HR. But the rest of this is kind of like, what are they asking us to solve for? They ask, on average, how fast did he run in miles per hour? When they ask us, how fast did he go? Or how fast did he run? That sounds more like asking for one word. You're asking for a speed. So I don't know what that is. That's my unknown. So I'm going to list it as V. Remember, V means speed. And so I'm going to put it as V equals, and I'm not sure what that is. We're going to solve out for it. But now that I wrote out what I know, what I don't know, I'm going to go back and I'm going to use a relationship that will help me figure out what I don't know. Here it's pretty obvious because we're dealing with speed, distance, time. There's an equation that goes along with that. It's this thing. Speed is equal to distance over time. So I put that in, and now that I have the equation, I can substitute this stuff that I know and don't know back into here. And here's kind of how I do it. If I don't know something, I just leave it as the letter. So in this case, I don't know speed. I leave the V or the speed the way it is. But the distance and the time I know, so I'm going to put those into the equation. So I put 26.2 miles, and I put the unit in up on top. And then for the time, I put 2.02 hours in place of the T. And now that I have things substituted in, now it works out really well where I can do the math with it and solve the problem. Here it's pretty simple. It's 26.2 and it's divided by 2.02. I can use my handy dandy calculator, and that's what you should use. If you need to use it on your phone or on the computer, that's fine for now, but we'll talk about that later. So when I type in 26.2 divided by 2.02, I get this. I get 12.97, and there's a whole bunch of other stuff after it. And so if I'm getting this on my calculator, I usually just cut it off to 2 or 3 decimals. So 2 decimals, you could use that, but don't write out the whole thing. Okay? But I'm going to list this as I solved for my speed, and I'm going to put in 12.97 from my calculator. This is part of my answer, but I also need to include units because this has a meaning to it. So 12.97 something. Okay? Where I get these units from, it's not a guess. It's really kind of from what I have, and it comes from kind of almost 2 places. One, it can come from your problem because they ask for the speed in miles per hour. They just ask for it. That's great. But it really also comes from your work because in my work I had miles over hours. And that's really what my unit will be for my answer. I'm going to put my answer in a box because that's what I solved for. That's just kind of shows that's my answer. All right, so that's problem number 1. Problem number 2 says Mr. Redmond is being chased by a bear and it took him 5 scary seconds to sprint to safety. If he sprints at a constant velocity of 4 meters per second, how far away was he from a safe shelter? Well, poor Mr. Redmond. So when I look at this problem again, we're going to go through these steps. We're going to list out things that we know, things that we don't know. So they do tell us that there were 5 scary seconds that happened here. And at 5 seconds, when I see seconds, I think of time. So I'm going to list in this section the time is equal to 5 seconds. We can abbreviate it, and you can abbreviate it a couple ways. You can abbreviate it with an S. Some people do SEC. Some people actually spell it out. That's fine. Either way, it's okay. And then it says if he sprints at a constant velocity of 4 meters per second, 4 meters per second, that's something else. But when I look at the unit kind of tells me a little bit about what that is, but I can also read around it because they tell us this is the velocity, or velocity, oh yeah, it's speed, it's the same thing, and it means it's the v. So our speed, or velocity, is 4, and it's m, just meters, and we say it's per second. And that's that piece. But then, for the part that we're trying to figure out, it says, how far away was he from safe shelter? When they say how far, again, we want to think of it as one word, how far. That's a distance. They're asking us for a distance. So it's the distance that we don't know. So now that I have the time, the speed, and we're trying to figure out what the distance is, we can use an equation to solve that out. It's really the same thing that deals with these three things all together. It's speed equals distance over time. I put in things that I know in place of those letters. You got to make sure that you put them in the right places. So the T is the 5 seconds. I make sure that I put in the unit. The V is the 4 meters per second. So 4 meters per second goes on this side. And then the D is on top. So when I solve this out, I'm going to solve out for this D. But now I got some things that I need to do because it's not always so straightforward. To solve for this D though, I have to undo something over on this side to get it by itself. That's really what I'm trying to do, is get it by itself. In order to get it by itself, I have to undo what's being done to it. Right now it's being divided by 5 seconds. To undo divide, I have to multiply. And when I do that, I'm going to do that to both sides of the problem. I'm going to multiply by 5 seconds and multiply by 5 seconds. When I do that, these 5 seconds, they go away. I'm left with just D on this side. And now I have what I really need to do to solve for the D. It's 5 seconds times 4 meters per second. So this one I can just plug in my calculator, or you could do this one in your head too, because it's 5 times 4. If I do 5 times 4, I get, oh yeah, 20. Okay? And that's going to be my answer. This distance, it's 20. But my unit, it's like, what's my unit? So the unit that comes in here really comes from what we did. We have 5 seconds, 4 meters per second. Well, I have seconds in 2 places. Seconds here, seconds here. But here it's seconds on top. This is like seconds on the bottom. It's like they cancel each other out. And what I'm left with one unit. I'm left with meters. And meters, that kind of makes sense. It's a distance. So distance, it's meters. If you're not sure, you can always check up in your units that were up in your problem. And here's meters, seconds, oh, meters. We're looking for distance. It's meters. And that's kind of the gist of that. So I'm going to pause right here. I'll make a second video for the third problem, and the fourth problem you're going to be doing on your own. But the third problem, that's where it gets a little tricky. So I'll see you guys in just a little bit.